Hi, and thank you for your question. This is a great question because it involves using skills from Unit 2 in order to write the equation with the proper chemical formulas. It also involves balancing the equation when the coefficients aren't whole numbers. So it has a lot of different components for this question. It is quite complex and not as straightforward as it would seem to be. So the first thing I'm going to do is I'm going to translate this from English into chemical symbols. So we need to write a balanced equation for a combustion reaction, and combustion reactions are when compounds react with oxygen to create new products. So our reaction is between liquid octane, which they do give the formula for, so C8H18, and gaseous oxygen. So we're going to be adding oxygen, and that becomes gaseous carbon dioxide, so CO2, plus gaseous water, H2O. So I can put a G behind all of these to show that they're gaseous. Now, this is probably the equation that you have, but it's not completely right. And that's because the formula for gaseous oxygen is not just oxygen, it's actually O2, because oxygen in its gaseous form by itself is a diatomic molecule, and we saw diatomic molecules in Unit 2, and those molecules, the acronym is Hofbrinkel. Remember Hofbrinkel the clown? So Hofbrinkel stands for hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. These are the elements that when they are by themselves in the gaseous form, they're always going to have the formula O2. That's where the dia comes from, or di comes from, diatomic, two atoms together. So that's the first thing. Do you have a 2 on your oxygen? Because if you don't, that's going to make it very hard to balance an equation. A lot of the times when you can't balance an equation, it's probably because you have the initial equation formula wrong. So something to remember. Next thing I'm going to do is I'm going to write down my elements on both the product and the reactant side. So carbon first, hydrogen, and I always like to leave oxygen until the end. Remember, if you follow the rules in terms of balancing, you'll have a much better luck at balancing the equation faster and more efficiently than not following any of the rules at all. So the first rule is to balance any metals first, and we don't have any metals, and then non-metals. So carbon is the first one. But first, I forgot, I have to count the atoms on both sides. So on my reactant side, I have 8 carbons, 18 hydrogens, and 2 oxygens. And on my product side, I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1 equals 3 oxygens all together. My oxygens are separated here, so I like to write them this way just to make sure that I count for them all. First of all, I'm going to balance my carbon. I have 8 on the reactant side, so I'm going to put an 8 here. That changes my carbon count to 8. It also changes my oxygen count. So 8 times 2 is 16, plus 1 gives me 17 oxygens altogether. Next, I'm going to balance my hydrogens. I have 18 on my reactant side, 2 on my product side. So I'm going to put a 9 here. 9 times 2 gives me 18, but now my oxygen count is going to be different. So I have 8 times 2 is 16, plus 9 times 1 is 9. That's going to give me 25 oxygens on this side. Now, this is where it gets a little bit more complex. I've balanced my carbons, I've balanced my hydrogens, now my oxygens I need to balance. I have to find a coefficient to put here that when I multiply it by 2, I'll get 25 altogether. And what I get is 12.5. 12.5 times 2 will give me 25 oxygens altogether, and now everything's balanced, except the problem is that the coefficients always have to be a whole number. So this is just going to be 12.5 I'm just going to put in here as a placeholder. What I have to do is multiply this by a number that is, by a whole number, that will turn this into a whole number. And if I multiply this by 2, I will get 12.5 times 2 is 25, and that will give me a whole number as a coefficient. It fixes this decimal, so I have a whole number. So that's the first thing. What can I multiply this by to make it a whole number? I can multiply it by 2. But if I multiply this by 2, in order to keep my balance across, I need to do it to all the coefficients on both the product side and the reactant side. So feel free to use a decimal just as a placeholder. Just make sure you then multiply it by a whole number. That will make it a whole number. And then whatever you multiply it by, make sure you multiply every other coefficient. So there isn't a coefficient here. We assume it to be 1. So my new coefficient is going to be 2 here. So I'll have 2 of these. 2 times 12.5 gives me 25 is my new coefficient here. 2 times 8 gives me 16, and 2 times 9 gives me 18 altogether. So I'm just going to clean this up a little bit. My new balanced equation is this after I've done all of the above. And that's gas plus 18 H2O. Lots of big coefficients here. I want to check that that's okay. So I'm going to count up my atoms on the reactant side and the product side, and hopefully they match now. So 2 times 8 carbon is 16. 16 times 1, that's going to give me 16 carbons on both sides. My hydrogens, 2 times 18 gives me 36 hydrogens on this side, and then 18 times 2 here also gives me 36 hydrogens on this side. So that's okay. And then my oxygens, I have 25 times 2 is a whopping 15 atoms of oxygen on my reactant side. And then 16 times 2 gives me 32, and then 18 times 1 gives me 18 oxygens, and altogether that is 50, and the equation is now balanced. So again, making sure that you have the correct formula for all of your compounds is super important. And then making sure that you have the proper counts, especially if you have atoms that occur in 2 separate compounds. You got to make sure that you do that correctly. And then what happens when you have to use a decimal number as a coefficient? You can do that, but then you have to do the fix where you multiply it by a number to make it whole, and make sure you do that to all the other coefficients as well. So thank you for watching. I hope this helps. It's a great question. Thanks for posting. Bye for now.